Good morning, I'm Brian Conley, and I'm also continuing on the filled resins, and we're talking about acrylic silica. The title of this article was Stereolithography Process Influence on the Rheology of Silica Suspensions and of the medium on polymerization kinetics cured to depth and width. And the scope was to investigate the effects of adding additives to PEAAM during the SL process. And the key questions are: how are the polymerization kinetics affected? And how are they influenced by the filler, the dispersant, and dilutant quantities in the actual resin? And over here you can see the SL process. The materials used were PEAAM, which is an amine modified polyester acrylate. The silica powder was purchased from Cirac here in the USA, and that was with a 2.25 micron diameter, so it's a really small, fine powder. PE is phosphate ester, and that was used as the dispersant to kind of spread those particles about the resin. Diacrylate was used as a dilutant later on in the study. They didn't actually make any physical bulk parts. They just made some lines in the resin and took some measurements of those. So they made 40 lines, 1 millimeter apart, 10 millimeters long, and then they actually washed them out with a solvent, coated them in another clear resin so that they could cross-section it and then take their measurements. And you can see the cross-section here where they measured the width and the depth. So the first question was, how does the powder loading affect the polymerization of the resin itself? At first, they started off with 0.5% PE and 0% HDDA. HDDA was the dilutant, so they're just using 0.5% dispersant with different silica powder weights. And you see they increased it from 0 to 10, 20, 30, and 40. And as they increased the amount of silica in the resin, the percent of conversion to the fully polymerized state decreased constantly, just a steady trend downwards. And also the rate of polymerization, you can see the peak dropped as well, which is expected if the full complete percentage is also decreasing. After that study, they decided to stick with the 40% silica, even though it had the lowest amount of percent conversion. And then they varied the amount of the PE, which is used as a dispersant, to see how that can affect that heavy dose of silica. So they increased it from 1% all the way to 5%, and there's actually a bit of an increase. It's really jumbled up in here. There wasn't much of effect, practically, with the dispersant. I mean, it maybe increased slightly and then decreased again as they added too much, but in the grand scheme of things, it all ended just under 70%. And then they also tried changing a dilutant material in there, adding that, and that actually had a bit more of effect than anything else so far. And you can see that with 0% dilutant, it's a pretty low value, and then it shoots up at 10% and then drops back down. So there's a value somewhere in there that's ideal for diluting that amount of silica. And the second study was to actually measure the depth and the width of the polymerization. And you can see here they've got some cross sections. As the silica increased, the depth definitely decreases, but you also gain a little bit of the width of the polymerization. And there's some values up there. They did note that up to 10% silica, there really wasn't a big change in the cross section, but after that it significantly decreases in depth, and you see a large increase, or minor increase in the width. And the key conclusions: silica loading of 10% does not affect photopolymerization. The viscosity of the SL fluid directly influences the kinetics of polymerization, and depth is reduced as the filler amount increases. My critique is that they didn't actually do any mechanical studies, so there wasn't anything about tensile strength or how this can apply to anything. They actually didn't mention any applications for this filler. I can only assume it's to possibly decrease the cost of the actual resin and maybe it has some strength characteristics that are beneficial, but the study didn't go into that.